Hi everyone. In this video, we dive deep into the designing of a rate limiter. In this video, we have discussed about the high level architecture of how a rate limit is being handled, like whenever a request is being sent to a rate limiter middleware, it uses the counter value to check whether the request can be forwarded to the API server or not, and to store the counter value, we use to mention Redis, which is an in-memory cache. To update the counter value, use the counter value to decide whether the request has to be dropped or forwarded to the API server. But the question arises, how can we use the rules? How we use the rules? Or like, where are the rules stored? And another question is like, in the previous video I have mentioned, if the counter value is more than the threshold, the requests are dropped. So how we handle the dropped requests? So we'll look into them one by one. First we'll explore about the rules. So basically the rules are implemented using Lift. What is Lift? Lift is an open source rate limiting component. I'll give the link to read more about Lift in the description. You can just check it about it. So it holds the various rules. We can see an example about it here. So this is an example which shows like the system is configured to allow maximum 5 marketing messages per day. So in this way, rules are defined in Lift, and once the rules are generally written in configuration files, so the rules are written, it is a open source, rules are written in config.yaml files, and they are usually stored in. And where are the rules stored? This was also one of our question, like if you just check where are the rules stored. So to answer it, the rules are stored in or saved in disk. So here we get our answer, like how we use the rules. So we use rules from Lift, which is an open source rate limiting component. And the rules of this is an example of one of the rules which we use. And rules are written in the config.yaml files, and they are saved in disk. So now let's move on to the next question, how to handle dropped request. So when a request is dropped, as we have also discussed earlier, like the API sends 429 HTTP response, which is a code for too many requests, and this response is sent to the client. So depending on the use case for dropped request, depending on the use case, we can also enqueue those requests to be processed later. Either we can drop them completely, and the client has to resend those requests in a completely new fashion, or else we can enqueue requests to be processed later. Let's say suppose the system is being overloaded and we need to process the request after a certain period of time, so we can enqueue those requests and we can process them later. But the question is, how does a client know? Like, I'll ask one question. How does client know request is throttled? So to answer that, we have already mentioned just now, like we have this 429 response, HTTP response, which is sent to the client. But another question is, how does this client will know? Suppose our request has been forwarded and we get an HTTP 200 OK response, but how does the client know how many more requests, it can send, or rather how many allowed remaining requests after throttle. So all these can be known from what we call as rate limiter. All this information can be got from rate limiter headers. So we'll understand this with the help of an example, like how does the header look and what the information does it store in it. So here you can see this is an example of an HTTP header with 429 response. So like it has too many requests. So these headers have certain parameters, or you can say like these are various notations which the header contains with itself. Like I'll say what this X rate limit means. So this is basically, it tells how many calls the client can make per window. So let's define them one by one. So like this is retry after. So this is basically sent along with the 429 response. So it tells the client how many, after how much time it should retry sending the requests. As the name also suggests, it's quite evident. After how much time, maybe it's in seconds or unit, any unit in which we are dealing currently, how much, after how much time we should retry sending requests, since currently the requests are being throttled and we are receiving 429 response from HTTP header. Second is X rate limit. So this limit says like how many calls the client can make per window time. How many calls per window time the client can make. And the remaining means how many, so like remaining means the number of allowed requests within the window. So the remaining allowed requests within the window. So since it's 0, because we are receiving 429 response, so the number of requests has been reached the threshold, so we need to retry after this, and so currently we can send 0 requests. So this is value is 0, and this value is the reset. So like this is a Unix timestamp, you can see. So this basically mentions like after how much time this counter values and all these values will be reset to its original value. So these are the headers which send us information to the client regarding whether the requests has been sent successfully, or else there are too many requests which has been already sent, and the HTTP header returns a 429 response along with all those informations, like when you can retry after, or number of remaining requests which are allowed for this time window, and all those informations. So in the next video we will see how this rate limiter is being implemented in a distributed system. First, we will look into how it is implemented in a single server environment, and next we will deep dive into its application in a distributed system. So thank you for watching this video. So I'll see you in the next video.